The derivative of a function allows us to identify peaks and valleys of that function. A peak is a point when a function is being maximized, and a valley is a point when a function is being minimized. Consider the following graph. We can see that when the function is being maximized, the slope of the tangent at that point, which is the gray horizontal line shown in this figure, is 0, because the slope of a horizontal line is 0. So we know that if we calculate the derivative at a certain point on our function, and it equals 0, that point is a maximum. Well, what about the following function? We can see from this figure that when a function is being minimized locally, the derivative will also be 0. And a local min or a local max just means that the direction of the function changes from being positive to negative. It's not an absolute minimum or an absolute maximum because we can see the tails of the function keep going up and down. So that's why we call it a local minimum or a local maximum. But regardless, we can see from this graph that we can't tell whether we're at a maximum or a minimum just by the derivative being 0, because the derivative of 0, if we're either at a local min or a local max, it's not enough to identify which one. So how can we tell? Well, there are two things that we must check. The first order condition, sometimes called the FOC, and the second order condition, which we'll call the SOC. To see whether a certain value x is a maximum or a minimum, we need to check if the first derivative is 0. This is known as the first order condition because it's checking the first derivative. If this condition holds, we know we're at either a maximum or a minimum. To determine which one we're at, we need to check the second derivative. If the second derivative is negative, x is a local maximum. And if the second derivative is positive, x is a local minimum. This is just something you have to memorize. You have to check the second derivative to identify whether or not you're at a minimum or a maximum. And this is known as the second order condition because you're checking the second derivative. And that's the end of the review on maximums and minimums.